with a, oh, that's right. Yeah, so yeah, make sure we're recording up. So I'm going to give you a little rundown of what exactly is DevOps with an example. So let us begin with, let's say there's a person named Bob, and Bob made a website, and Bob has his website on his laptop, and he wants to make sure that this laptop or this website can be reached by customers. Well, what does Bob do? Well, Bob has several options. Bob has the option to host his website on his laptop, right? But what does that mean, right? What are the implications of hosting a website on a laptop? So let me just clarify some terms, right? Hosting a website, that means like that the website when you log in on, let's say the IPT Learning, right? That a website is being hosted on a computer, right? In order for you to access that, it has to be running. So by hosting a website, it means it's running on Bob's laptop. So what are the implications of running this website on Bob's laptop? Well, if Bob turns off his computer, people will not have access to this website. So Bob has to keep his laptop on and always running. So Bob's like, well, this isn't convenient. What can I do? Well, Bob decides to buy another computer, and he starts hosting that website on this computer. And now it is called, that is usually called a web server, right? This computer is a server. So now this website is running on this server, and now hundreds of people can access that website. Well, as the website starts growing, more people start coming in. Bob wants to introduce new features. And when introducing new features, you want to make sure that they actually work before they're introduced to the public. Well, what Bob needs to do is that he needs to run tests. And these tests, as they become more and more complicated, they take longer and longer to do, right? Bob can do these tests on his laptop, but, as they become more intensive, the computing power on his laptop isn't good enough. And, again, his laptop starts to be used for something else, so he can't really use his laptop. So what does Bob decide to do? Bob decides to, okay, well, let me make a test server and run all these tests before I deploy to my web server. So what happens now? Well, when Bob, let's say he introduces a new web page, he wants to make sure that everything works. He sends his code to the test server. The test server runs these data points to make sure everything works, make sure all these tests work. And once they work, Bob then sends his new website into the web server. Now, this becomes as you're seeing, it's become a couple more steps, a little bit more complex, and it's become a little bit more streamlined, but some new things start happening. Well, let's say that Bob keeps on introducing new things, right? New pages, new features. Every time he introduces a new feature, he has to manually push all these tests into the test server. And then once they complete, he has to move all that code into a web server. And that can become very, very tasking, right? Well, Bob starts to think, well, how can I do this in an automated way? So Bob finds out about this thing called CI/CD pipelines, which means continuous integration and continuous deployment. These pipelines allow you to automatically run these tests when you push new changes into a code repository. A code repository is a place where you could store all your code, right? So what's the flow now? Well, Bob makes new changes. He introduces these new changes into the code repository. Think of it as a bank, essentially, where you store everything. He introduces these new changes into his repository. He can now run automatic tests when you introduce them into the repo. And once these tests are passed, he can just click a button and they get deployed into the web server. And now, rather than him having to manually send code to the test server and send code to the web server, he can just click buttons and it automatically sends the code through this different pipeline. These are called CI/CD pipelines. Some tools that are used to that can do this are GitLab pipelines or Circle CI. These are all continuous integration and continuous deployment tools, which you will be going over later in this course. So Bob is happy, right? And what happens now? Well, Bob starts having a lot more traffic. He's really successful and he starts having a lot more people coming through his website. And he's running into an issue where his website isn't loading as fast anymore because there are lots of people requesting data from his website. So what does Bob do? Well, what can happen is that, Bob, since he has another computer and he's managing that computer, he only has one, right? Well, what happens if that one computer goes down? Well, nobody can access that website, right? So there's a lot of overhead with having something local. So Bob ends up finding out about something called the cloud, right? The compute cloud, right? Some of these cloud computes are called, some of the people that provide this computing power are AWS, which is Amazon Web Services, Azure, which is a Microsoft version of these web services, and Google, which is called GCP. These all provide computers where you can rent, right? So what happens now? So Bob finds out about the cloud and he decides to host his website and his test server on the cloud now. Let's say he chooses AWS, right? So now he has his servers on the cloud. He doesn't have to manage these servers now. He doesn't have to worry about, oh, what if they turn off? Or what if, I need to scale these up or down? He doesn't have to manage a lot, right? Because now they're being managed by a third party. So cool. So now Bob has his web server online and he has his test server online and people are happy. And y'all can see that, right? Okay. Now, let's say Bob is really successful and he brings on 2 developers, right? Well, these developers have to communicate with each other with code, right? With their code, that the job that they're doing, right? So right now, Bob only has all his code in his computer, and Bob has to find a way to share code between his new developers. Well, what Bob can do, like I've said in the past, right, a couple minutes ago, Bob can introduce something called a code repository. It's essentially a storage where you could save your code, right? So Bob can now push his code, or that means you're saving it into this repo, this code repository, and now his new developers can all work from that same code base. So this allows you to have multiple people working on different tasks, and that allows you to be more efficient in your tasks, right? Because now people can do different things and they can all share this one repository, right? Called the code repo. When the repository, you might have heard of it, is GitHub or GitLab. Those are all popular repositories. There are some other ones that are a little bit more niche, such as Bitbucket. That's another repository that you could use. So let's introduce the next thing, right? So his website becomes really popular. Now he has 2 developers, he has a repo, more people are being driven into the website. So what happens now? Well, Bob, he introduces a new server. He adds another web server to manage traffic, right? So now rather than having one web server, as we see here, Bob now has 2 web servers, right? So how does Bob manage traffic into these web servers? And let me clarify a term. Well, what is traffic? When you click on a website, that request is being sent to a server. That request that you're sending, that is referred to as traffic, right? Because you're sending information, bytes, through the internet that will hit into the server, right? So this is referred to as traffic. So now you have a lot of traffic routing into 2 web servers. And Bob has to figure out, well, how do I efficiently route traffic between my 2 web servers? Well, Bob can add something called a load balancer, right? And don't be, you might be confused right now, all these terms that I'm dropping. We will go over them, but I want you to get a mental picture of what's going on. So there's this thing called a load balancer. What a load balancer does is that everyone hits one endpoint, right, where all the traffic meets, right? And then from that point, all the traffic gets routed to your two web servers. So what a load balancer does is that it makes sure that these two load balancers have an equal amount of traffic, right? So this load balancer is in front of my web servers. So rather than Bob worrying about buying some form of router or load balancer like locally, like him having a president in his house, he can add a load balancer using the cloud, right? And you can host these things on AWS. And something starts happening, right? He added another server, he added a load balancer, and things are starting to add up in cost, right? So it happens to be that maybe Bob realizes that on Mondays and Wednesdays, traffic is really high, but on Tuesdays and Thursdays, traffic is really low. Well, what does that mean? Well, that means that on Tuesdays and Thursdays, Bob doesn't really need the second web server. So what can Bob do? Bob can introduce something called an auto-scaling group, right? What is an auto-scaling group? So what Bob can say is that, okay, depending on the traffic coming in, I can have two web servers. And if the traffic is really small, I can have one. And this is really nice because now, depending on the traffic coming in, on the amount of traffic coming in, it can scale up or it can scale down, right? It can scale, this is called scaling horizontally, right? You're just introducing much more of the same unit, of the same web server. So this is really nice, right? So this saves Bob a lot of money. And let's see what happens now. So if you see here, let's say this is Monday, you have a lot of traffic, you're running two web servers. Let's say on Tuesday, you have a little bit of traffic. It scales it down into one. So Bob is able to accomplish that with an auto scaling group. So that was a lot, right? So let's talk about, what exactly Bob did. So Bob hit a lot of things when it came to DevOps. He touched infrastructure. He went from hosting things locally into hosting things on the cloud, right? And remember, the cloud is AWS, Azure, or GCP, right? And these are just places where you can host, or you could rent servers for a specific amount of time, right? So you pay for what you use. So you don't have to pay for the entire computer. You just pay for the amount that you're using for that computer. Bob also touched scalability. Bob is able to scale up and down depending on traffic. Bob also touched things such as version control. He introduced a code repository where his developers are able to share code and different versions of that code. He was able to observe stuff, right? He was able to see, well, how do I know when to scale up or down? Bob needed to know when this needed to happen. So this is called observability. And when things started to get really expensive, Bob was able to manage costs by putting things in the auto group. So Bob was able to keep costs in mind while managing his infrastructure. And last thing usually is security. Because you have things on the cloud, you don't have to manage a lot. The security that you have to manage is a little bit stricter. So you don't have to worry about a lot of, not that you don't, right? But security it's a little bit more secure when run on these other services, because they have to comply with these security standards. So Bob just touched all these aspects of DevOps. And if we see here, DevOps isn't just one specific thing. DevOps touches everything when it comes to code, when it comes to a software engineering company, when it comes to, when you make a code and it builds a code, right? What does it mean to build? Well, sometimes you need to run tests. You need to do something called linting, right? You format code. After you format things, you can test them. After you test them, you deploy them. After you deploy them, they have to run on the cloud, right? So after they're running, you have to make sure that things work. And if they're working, well, you have to make sure that they keep working. How do you know if something stops? You have to know when these things stop. On top of code, you also have to manage people, right? Who some people should not have the same access as other people, right? So you need to know who has access to what. And then lastly, notifications. Sometimes things go wrong. So you need to be able to notify the right people about things. So as you can see, DevOps touches everything, from the start of starting of making code and at the very end. Even if you're not an engineer, DevOps touch every single part in terms of a software engineering team or company. And there's this philosophy where, DevOps essentially what it is you link the software side of the business with the business end, and you help both sides accomplish your task. It's essentially you are the entire glue of the company, right? Because the software team has their own tasks to complete, and the business team has their task, right? So the business tells the software, and the software hands it back to the business. So this is all one loop, right? And DevOps allows the software team to continuously integrate and develop new stuff so the business end can be successful. So essentially, if you want to think about it, you are the glue of a DevOps of the company when it comes to things. And here's a little picture. So when it comes to what exactly a DevOps engineer will do in a company, there are a lot of different tools that exist, and usually DevOps in all these other companies will be a little bit different, right? As a DevOps engineer, you will make tools that will help other engineers accomplish their task, and as well as the business end. So for example, typically in a more mature software company, a DevOps engineer will usually be after the release, deploy, and operate. They will interact after the testing stage. But even before that, let's say if a software team or software company was just starting up, a DevOps engineer will start from the very beginning, from the planning phase to the operate phase. How? Well, a DevOps engineer will make the code that will test everything. They will make the code that will integrate the stuff. They will make the code that, or make the repos, make sure that people have the right access. But typically in a established software company, a DevOps engineer will be, usually their end is after the testing, because it assumes that everybody has proper testing already, and they will be more in line with the releasing, deployment, and the operation of these things. So we're starting to dip into a little bit Linux, but I want to talk about Windows and Mac. All right, so many of you are probably familiar with Windows. It's, I think, the most popular consumer operating system in the world. And there is also Mac OS. Mac OS isn't as popular, but it's pretty popular in the States. These are the two most common consumer operating system. And there's another one that a lot of people don't know about, and it's called Linux. Well, why? Where does Linux fit into this? Well, while Windows and Mac OS are very popular on the consumer end, they're not exactly popular in the enterprise world. A lot of the code, or a lot of the websites that you see online, they're not hosted on Windows, they're not hosted on Mac OS, they're hosted on Linux. And the reason that is because Linux is free to use. Linux, or depending on the version of Linux, right? But Linux is open source and is free to use. And I think there's some impressive metric that like 65%, let me see, let me refer to my notes real quick. That almost 50% of all workflows on Azure are ran on Linux, right? Azure is the Microsoft cloud compute. So Microsoft has their own Windows web servers. So even on Microsoft's hosting service, Linux takes more than 50% of their servers. So Linux is very popular in hosting these things. And now we're getting into our Linux introduction. So does everybody understand with the Bob thing? Essentially, Bob just had a website. He learned from hosting it from his computer to hosting it on a server online